All right, these are two-dimensional forces looking at hanging signs. Hanging signs are not accelerating. They have a constant velocity, with that velocity being zero. Any of the forces that are at angles, we want to break them into their components. What is horizontal? What is vertical? They've given us T1 is on the left. They said that the angle is 50 degrees. We're going to move that angle into the triangle and so that we know where that 50 degrees is located. Same for T2. We can see that the leftward component of T1 is equal to the rightward component of T2 because there's only one leftward force and one rightward force. They're equal, balanced forces. The horizontal component, since it is adjacent to the angle, it's T1 cosine 50, and on the other side, T2 cosine 42. The vertical components are T1 sine 50 up and T2 sine 42 up. Going down, we've got mg, and since mass is 25, mg, force of gravity is 250. Now that we have our free body diagram broken down into the pieces we need, let's do our net force equations. Left is equal to right. T1 cosine 50 is equal to T2 cosine 42. Let's simplify that and just divide the cosine of 50 to the other side so we can solve for one of our variables. T1 is equal to T2 times cosine of 42 divided by the cosine of 50. If we put that in our calculator, be very careful how you do this. I typed in cosine of 50 equals and then cosine of 42 equals. When I got that second answer of cosine of 42, I was able to just hit the divide key so it calls up my previous answer. Then I arrowed up and found the answer for cosine of 50. This makes sure that you have all the parentheses in the right place, otherwise the calculators can give you the wrong answer. Here I chose to use 3 decimal places. We accept 2, but because I know a lot of the math classes ask for 3, I'm going to just use 3 decimal places on this worksheet. I got T1 is equal to 1.156 T2. And that's simply for solving for cosine of 42 and solving for cosine of 50 and dividing that to the other side. Looking at my vertical forces, I'm going to add up my upward forces and set them equal to my downward force. T1 sine 50 plus T2 sine 42 is equal to 250. We're adding those two because they go the same direction. They're both going up. Now I've solved for T1, so I can plug in where T1 is. I can plug in what T1 actually is. So instead of T1, I'm going to put 1.156 times T2. That's still being multiplied by the sine of 50, because if you look at that formula, it's being multiplied by that. And then we're going to add T2 sine of 42 is equal to 250. On my calculator, I'm going to go ahead and resolve 1.156 times the sine of 50. That gets me so many T2s. And then I've got T2 sine 42, so I'll resolve the sine of 42 or calculate the sine of 42 so that I can add like terms. I end up with 0.886 T2 plus whatever the sine of 42 is going to be. Let's see, 0.669 T2. So I've got like terms. I can add those together now. When I add those together, I get 1.555 T2s is equal to 250. This is mostly doing algebra, maybe algebra 1, maybe algebra 2. I'm going to divide the 1.555 to the other side, so then I've solved for T2 with an actual number. And I get 160.772 newtons. Again, when you round it off, when you calculated how you calculated how many decimal places you carried, you might have a little bit different value, but it should be fairly close. Now that we know what T2 is, we can go back to our original equation and say T1 is equal to T2, which is 160.772 times the cosine of 42 divided by cosine of 50, or just simply say it is equal to 1.156 times T2 of 160.772. So my T2 ends up being 185.852. .852 newtons. Just plugging that into the original equation since I solved for T2 in the second equation. Well, that's the first one. That's great. If they give us two different tensions, we were able to come up with two different equations. With two unknowns, you need two equations, an equation for every unknown. This time they told us what T2 is, but they didn't tell us what the mass is. Don't worry, we've got the skills to take care of this. T1's broken into its components, the leftward component and the upward component. The leftward component being adjacent to the angle, so T1 cosine 55, And the upward component, the vertical component, is on the opposite side, so T1 sine 55. On the right, they tell us T2 is 56.6, so let's just go ahead and label it 56.6. The horizontal component pulling to the right would be 56.6 cosine 25 because it's adjacent to the angle. Going upwards on that right side, it's on the opposite side, so 56.6 sine 25. Now we can calculate both of those in our calculator, so let's go ahead and do it now. If you do it later and carry the decimals, you might get a slightly different answer, but it's just rounding errors and it's not going to cause an issue. We want to make sure we understand the problem. 56.6 cosine 25, put it in my calculator, I got 51.297. On the vertical side, 56.6 sine 25, I got 23.920 newtons. Well, the good part is the horizontal component's going to be fairly easy and straightforward. T1 cosine 55 to the left is equal to 51.297 to the right. Left is equal to right. These are balanced forces. Our signs are not accelerating. They have a constant velocity of 0. So I've got T1. I'm going to find out what cosine of 55 is. And then in my calculator, I type in 51.297 divided by that answer I got previously when I calculated cosine of 55. When I did that, I got 89.434. You should have something very close as well. Now that we've satisfied horizontal, let's look at the vertical. We know that both vertical forces going up are going to be added together. They're going the same direction, and that's going to be equal to mg down. M being the mass and g being the acceleration of gravity. Mg is the force of gravity. So T1 sine 55 plus what we calculated on the right, 23.92, is equal to mg. The two up added together is equal to the down. I can go ahead and satisfy what T1 sine 55 is because I know T1 is 89.434. So my calculator, I did 89.434 sine 55, enter, got a number, plus 23.92, enter, got a number, and that number is 97.18. 97.18 is equal to mg, but we know g is 10, so we're going to go and say m times 10. Divide both sides by 10, we get 9.718 kilograms is the mass.